glass. Break it.
You didn't know
really
that?
Small little bit of glass. And when you see that it glows, you shake it up and it glows, that is called chemiluminescence. That's when a chemical reaction creates light. So I'm going to show you a really big glow stick in this jar. Could we have the lights?
Yeah.
And you're going to help me. Yeah. Here, you're going to help me. With the science experiment, not the lights. Okay. So, here I have something called hydrogen peroxide.
I've heard of it.
You know this. So,
It's in the sun.
it is in the sun. So, hydrogen peroxide is very close to water. Water is H2O. Hydrogen peroxide is H2O2. So, it's very close to water, but we want to make sure that we definitely do not drink it. Yes. Hydrogen peroxide in here.
It sounds like water.
Yes, it also looks like water. A lot of things look like water, but they are not water. So, if we think something's water, we definitely don't want to drink it. Good job, guys. So, I'm going to put another thing in this hydrogen peroxide. I'm going to put luminol. This. You've heard of this? Oh my God. You're a musical scientist.
Oh yeah, I love dubstep.
That's a scientist.
Yeah, almost everyone knows that I love dubstep.
So, I know you did. I know you did. We're going to put
No, that's my neighbor.
some luminol in this. And we're going to stir it around. Here, please stir this around. So it all looks together. Good job. Good job. Okay. Awesome. Now, here, you want to stand on this side of me so it's a little bit darker? Okay. So I'm going to hold this, and you're going to pour this.
It's gonna
inside
glow.
here. And this is going to be a big, so you can just push the bottom. Just push the bottom. This is a gigantic glow stick.
Okay, that's really cool.
Yeah. Don't let it overflow.
Yeah, never.
So it's on chemiluminescence, and that's what happens in every single glow stick.
I'm-
You have a question? What's up?
It looks like there's 2 layers.
So that's what happened at the beginning. That was a bunch of bubbles. So the chemical reaction is mainly light, but it also created a bunch of, it's kind of like tiny explosions, like air. Fizz. Which are bubbles.
It's not really
Yes.
glowing.
I have a big other question.
Okay.
Did you for the class, did you know that I have one of those little guys right there?
You do. We're gonna move on to that right now.
And guess what? When you touch it,
It
almost
goes to your hand.
You're spoiling the show for them. Okay, you can have a seat for us. Thank you very much. Yeah, can we give an applause for our assistant?
Emily, did you have a question?
Yeah,
You have a question?
okay. I want to know if
Jingle bells.
hydrogen peroxide.
Hydrogen peroxide. Very close to water.
Would there be reaction if it touched your skin?
No, there would be no reaction if it touched your skin. Nothing would happen. Okay, so what we have here, let's all sit back down, everybody. We got
Hey,
a lot
everyone,
right
on the chairs.
here. So, has anyone ever seen this before?
Yes, it's a thing.
This is called a Tesla coil. Do you guys see something at the top of it?
Yeah, it's like a lightning bolt.
What color is it?
blue, purple.
Purple.
My favorite color.
Perfect.
It's,
So,
My least favorite.
this
it's like a mini lightning bolt.
lightning. It's not just electricity. This is exactly what falls from clouds. This is lightning. And if I
Touch my
bring this
finger.
light bulb really close to this lightning,
It will light up.
it'll light up like that.
I've
Then
known
if I
that.
bring it close to the edge, whoa, whoa, you see a lightning bolt. And what color is that again?
Purple.
Purple. So what's happening here is there's a bunch of electrons in this, and it's passing through this. So this is all electrons that you're seeing. That's what makes lightning. What's up?
What would happen if you got struck by lightning?
You'd probably die, or else if you're smart, if you're
There
lucky.
might be a lot of things can happen, but you don't want to be struck by lightning. So we saw that the lightning was purple. You have a question?
Like real lightning, like the big ones, all they white.
They could be white or purple, mainly purple. So, in our air, the atmosphere around us, it's air. It's a lot of oxygen and nitrogen. Let's hold our questions till after this. And you see the lightning is purple. In this little container here, it has a different gas than air. And here is neon gas. You guys ever heard of neon lights?
Yeah.
So if I bring this really close to this, instead of purple, you can see this still lights up. It's actually orange. So the color of lightning is completely dependent on whatever atmosphere that it's in. This also has a different atmosphere. But yeah. So what we have over here. Does anyone know what this is called?
Plasma ball?
Plasma ball.
It's a plasma ball. You guys are saying. Where do you guys learn this?
School. Yeah.
I read it for fun.
Doug.
Okay.
First grade.
So
Kindergarten.
when I turn this on, we can see it right there. Same thing. It's going all around. If I touch it like this, you see a little. This is also lightning. This is a little bolt of lightning. And remember what I said when I did this, lightning is all electrons.
Oh, also, if you put your entire hand on it, there's only one pot of lightning.
That's exactly true. Because the electrons, what they're trying to do is, right now it's trapped in this ball. And what their goal is to connect to the ground as quickly as possible. This little plastic is stopping that from happening. It can't pass through this plastic. So it travels the fastest possible route to the ground. So if I put my finger here, it travels up my finger, down my leg, to the ground. So if I have 5 fingers here, you're gonna notice that it usually, maybe it'll come into 2, but the electrons will take the fastest route possible to the ground. Theo, do you want to try this?
Oh yeah.
I want to try.
Here, how about we make a big line and you guys can all try the plasma ball. All the electrons will pass through.
Come here.
You can get the cake.
You can use one finger and drag it around. There we go.
When I put my hand on there for long enough, I kind of feel hot.
Yes, so that's a little tiny bit of electricity that's passing.
It's like drawing.
Okay, yeah. That's all goes
Yep, go right there.
cool. And then you guys can go sit back down once you're done.
Hey, look, I don't have to wait in the line because I'm small.
When you
You
get
guys can also try touching that. Let's go
2
back.
years ago. No, a year ago.
Okay.
This is gonna be
Very cool. Electrons passing through your whole body.
Oh my god.
You got another one over there. So you guys will also notice that there's different colors of these ones. This is a little different. That's because the atmosphere in the ball is actually different.
It is super cool.
Electricity. Very
That
cool.
was so cool.
Okay, when you guys are done, we're gonna have a seat and we're gonna start the next experiment, okay? Start down. Make sure you all get a try though.
Theo, what's the one?
Okay. Can we turn the lights back on? Actually, you know, it's fine like this. It's really cool.
Well, cake?
Okay. Okay, that lights back on. One more, and then we're gonna start.
This one fell down.
Okay. Can you close it over there, my friend? Thank you.
Can you guys?
Okay.
It fell down.
So, the next experiment, we're going to use a little bit of fire.
Yeah.
Don't worry, it's gonna be completely safe.
Aww. Man.
Sit back down. Sit back down.
Safety last.
Okay. What do you guys see in there?
What just happened?
Money.
Money. $1 bill. Okay.
You want to build a house?
No, that's a terrible waste of trees.
I'm going to I'm gonna drench this $1 bill in a liquid. Actually, since you're doing
It's
fire,
oil.
let's take a little step back.
I have dollar bill though. Why not just normal paper?
Right behind.
You're wasting trees.
So you guys are gonna see how I can set this dollar bill on fire without burning it at all.
What?
Oh yeah.
Actually, that is very interesting.
That
I know.
is true. You can do
Oh,
it somehow.
Okay, so
I don't know how to.
you completely drench this dollar bill. Very wet.
not drenched. The top
There's a book with people.
Okay, I'll flip it over just for you guys.
Can I set up close
You already burnt it.
Yeah,
It was burned. Can I set up
It's not disintegrated though. Oh, careful.
No, I have regular paper.
Can I put
My
these
fire.
on
So,
fire?
Or I think you have.
That's what you want.
You're wasting trees right now.
Yeah, so
Oh no! Fire!
okay.
Fire's coming.
Okay. He knows what he's doing.
It's burning.
So, $1.
And it's not burning.
I love
It's a Canadian dollar, right?
Not a Canadian dollar.
It's American.
That's why he's like,
USA.
So,
Eagle.
does anyone think they know what happens? Do you
get a
know?
Canadian?
What happens?
about the Canadian.
It just burns and like it turns like black, and then when it gets burnt enough, it just pokes a hole.
You're right. That was the chemical reaction. So, why that happened? Does anyone think? So, it has to do with the liquid that's in here.
Water.
It's not water. Once again, it looks like water. Water always fools you. It's not hydrogen. This is rubbing alcohol. And rubbing alcohol is very, very flammable. And when something is flammable, that means it catches fire, it ignites at a very low temperature compared to other things. This rubbing alcohol ignites at around 300 degrees Fahrenheit.
That's
But
not.
the paper ignites around, or the cotton, money's a little weird, ignites around 450 degrees Fahrenheit. So when I set this on fire, let's do it again. What happens is all of the rubbing alcohol is completely burned up.
Can I set a potion on fire with this method?
That would not be fun.
Wow.
All
That's Miles'
of
sister.
the liquid is completely burned up
That's why
and turned into
all my
nothing
stuff is
before the dollar bill can get to 450 degrees Fahrenheit. You have a question?
I'm really happy that you can't really smell that, but I'm happy that it's not setting off our smoke detectors. Because it's gonna be really loud. Because
Does that ever happen? The whole house goes.
I usually make sure that there's none in here. But you'd be surprised. Okay. Now.
Why would we be surprised?
What
happens?
We're gonna do, this is my favorite one. So,
I mean,
this, can you guys guess what's in this fishbowl?
water.
It is water. This one actually is water. So, when I put sand in water at the ocean, is sand, is it on top of the water or is it below the water?
Below.
Below the water.
Because it sinks.
It sinks. So this is a special kind of sand. This is called hydrophobic sand.
And it has air in it, so it'll
It's
float.
gonna float on top.
It can't get wet.
so cool.
It's going
It can't get wet. You're exactly right.
Actually, I did see a video of the sand getting wet, but it's
So the word hydrophobic, we're gonna break it down into two things. Hydro, what's hydro?
Water.
Water.
Greek for water.
Phobic, does anyone know what phobic is?
Phobia.
Afraid of it?
Yes, afraid. Fear, like phobias.
It's afraid of water.
It's afraid of water, so it won't allow it to absorb it. It tries to get as far away as possible. Some of it you'll see actually falls to the bottom. That's here, I'll hold it up so you guys can see. Some of it falls to the bottom. You guys can sit back down. It falls to the bottom. That's because it gets so heavy that some of it will start connecting to each other and it'll get heavy and it'll fall.
Dang, a tiger.
So, something very cool about this is I'm gonna call a few of you up. Hold on, guys. Let's sit back down. We can play with that after, okay? Come on, guys. Sit back down.
That was making noise.
That's okay. Don't worry about it. Just
It's okay.
Yeah.
So,
What happened?
if I have all this hydrophobic sand on top, and I dip my finger inside, you guys are gonna see. If I do it
Your
very
finger
slowly,
won't get wet.
finger won't get wet at all. If I very slowly dip my finger in.
I like Trolley, so I want to play with
You look like 2 times bigger underwater.
I know. Wait, you
It doesn't get wet at all.
Can I
Peter,
try?
will you come up
Let me.
and will you hold on? Peter's gonna go first. Here. It's totally safe. Here, let's sit down so everybody can see. Let's make sure we're sitting down. Now, hold on. You want to make sure that you go very, very slowly, because the hydrophobic sand is trying to stick together and connect to itself because it's very scared of the water. So we're going to go very slowly.
It's like autos.
And only put in a little bit of your finger. Super slow. Try not to jerk it around.
I can go.
How is that even possible?
The sand covered it.
That's
Okay,
crazy.
let's create a line. Hold on. Let's go over here. We're gonna create a line. Let's make sure we're open this line. You guys just dip your tiny bit of your finger in, and then we're gonna go to the back of the line. We got a lot of size experiments to do. Oh, there we go. Is it wet?
No.
Okay.
How is that even possible?
And when you're done, you can just sit right back down.
Sand can't stick to your finger because the sand is super dry. Only wet sand sticks to your finger. And sometimes when dry sand sticks to your finger, that's because your finger can be wet.
Okay. And then we take it out.
Is it wet?
And you go sit back down. Okay.
My hand's not wet.
Now we don't want to take too long because next we're gonna try dry ice.
I love dry ice.
Dry ice.
It's ice that
You
is
guys are already
ice
scientists.
that is dry and it's so cold that it.
You have a question, Theo? Hold on, everybody. Theo has a question. Let's listen.
I'm a little bit concerned about the dry ice. I'm scared that all of like the little ice gonna get everywhere.
The smoke. So, dry ice, the smoke that comes out of it, is the same smoke, it's the same gas that we breathe out.
Yeah,
So it's completely safe.
it's like an ultimate. It's like an ultimate.
It's because the temperature in the air and the
I was like, oh god, wait, as soon as I did I took it out and I was like, oh.
I got something. Don't worry about it.
It's literally just dust on the finger. Yeah. You don't feel anything. I'm wiping it on you. Yeah, it's
Okay.
cold until you take it out.
I'll do this video.
Almost done.
we're gonna. Yeah, don't worry. We'll keep it about 30 minutes. It's okay.
It does. My hand's not wet. Feel it.
Mm-hmm. Not wet at all. Okay, let's go sit back down after we're done, okay?
When you touch it, it feels wet.
It feels right. I'm used to always being finished with
Okay,
lunch.
do we all try?
Yeah.
Everybody try? Okay, let's all sit back down. We're going to use some dry ice right now. So, when using dry ice, you want to make sure to use gloves. Does anybody know why?
Because it's freezing and it's so cold it feels hot.
You're right. So, does anyone know how cold it is?
0.
Hold on. Let me call on you. So we know. How cold do you think it is?
Negative 120 degrees.
Very close. It's negative 151 degrees
That's not
Fahrenheit.
I want our carpet to get like.
Yeah, it's gonna be
It'll be fine. He knows what he's doing.
Yeah. So, yeah. It's totally gonna be okay.
Very comfortable.
I'm so I'm not
Oh my god.
This is a block of dry ice.
It kind of looks like foam.
Remember, like foam.
Why does it make your hands feel like they burn when you touch it?
So, that's a good
No,
question.
it'll burn your house.
So, in our hands, in all of our skin, we have,
Dead body cells.
we do, but we have dendrites in our cells. And those pick up all of, basically all the senses. So for skin, it's touch. We feel touch. Now, when something is so aggressive, like heat, for example, when it gets to almost below like negative 50 degrees Fahrenheit, it doesn't know how to process that pain because it's just so aggressive and no human has ever experienced that.
hammer.
So what happens is your brain tries to figure out the worst possible feeling so you can basically make you get away. And that feeling is fire. That's why it burns instead of freezes.
So we're just cavemen.
Yes, for a caveman. I've never touched cold things before.
Get away.
Okay. Does anybody know what dry ice is made out of?
Yeah.
Mist.
Dry ice.
Mist. It's not
Water.
It's actually not made out of water or
It's made
ice.
of dry ice.
It's a very misleading name.
It's made out of dry ice.
Okay, that counts. It's made out of dry ice. What do you think?
Dry ice. Atom.
It's made out of carbon dioxide.
Good job. It's made out of carbon dioxide. So, if you guys all breathe in with me, and we breathe out,
Carbon
that is the exact
dioxide.
Same thing.
Amelie, do you have a question?
That is this block. Oh, do you have a question? I'm sorry, I didn't see it.
How do you freeze carbon dioxide?
We create a tiny little atmosphere. So kind of like what we have here, we create a ball, a little atmosphere, and we freeze it. We make sure it's full of pure carbon dioxide, and we freeze it.
Do you know what temperature it freezes at? Is it the same as ice or
No, definitely not the same as ice.
colder?
Yes. Dry ice is, it should be negative 151. That's its natural state. Okay. So you're right, it's carbon dioxide. Do you guys know in the winter when we go outside and we breathe out, and you guys see that smoke? Do you guys know that smoke? So that fog, that smoke, is the same exact thing that we see here. Carbon dioxide is special because when it changes temperature rapidly, like from our warm bodies to cold outside, it creates this smoke that has a color. So right here it's going from cold to hot, and it creates this smoke. The same exact chemical reaction happens in our bodies as it goes from hot to cold, and it's the same smoke. Okay. Do you have a question?
Yeah.
What's your question?
I thought it was made out of liquid nitrogen, and also, can you make a bubble? Can you do the thing how it makes like a bubble?
We're gonna do that actually. That's what it is. So, nitrogen is related to dry ice because fire extinguishers uses a lot of dry ice to extinguish fire. But it's a combination of dry ice and nitrogen.
Interesting. I never knew that.
Yeah, good job. We do an experiment where we can actually make a fire extinguisher. Well, this counts as a fire extinguisher. Carbon dioxide immediately puts out fire like that. So this is a tiny little
You're
fire
blowing
extinguisher.
it.
Well, that's here. There we go. This is a fire extinguisher. So, perfect time, boiling water. So, I have my flask here. Now we're going to create a very big chemical reaction.
Ooh. Yeah.
This is boiling water. Around 100 degrees Fahrenheit.
Could I be next to you?
This dry ice, does anyone remember how cold the dry ice is?
151 negative degrees.
Negative 151 degrees.
I don't have any.
So, this is a temperature change instantly of, does anyone know? Can anyone do that?
Wait, what is that again?
100 degrees.
It's 100 degrees.
So that would be 51 degrees Fahrenheit.
Yeah.
Temperature change is 250 degrees. So,
Well, I thought.
when I drop a little bit of dry ice in here, a huge chemical reaction happens.
And you saw the water actually.
Yes.
It's like boiling down there.
So it's not boiling.
How hot is it there?
The water is 100 degrees Fahrenheit. And this is negative. Here, guys, let's sit down. I'm gonna pass it around so we can all.
That's so
Really?
Somebody laid on my finger.
Seriously?
So, carbon dioxide gas. Ooh, oh, you guys see. So, what happens is if I put a little bit of soap in here,
Oh my goodness.
Oh my god.
it creates carbon dioxide bubbles.
It kind of looks like
So,
a tea.
what happens here is it's bubbling because it's boiling, and the bubbles, instead of filling up with air, it's filling up with carbon dioxide. And when they pop, it turns into carbon dioxide like that. You have a question, Theo?
Yeah.
What's your question?
If you could like get enough of those, like
Mhm.
everywhere enough to fill up a house, could a house actually be filled up with bubbles
It definitely
everywhere?
I mean, how can we fill it with anything?
Especially, but it'd be more fun if it was filled up with bubbles.
smells so
Okay, so we're gonna make a line in front of here. Theo, you're gonna be first in line. And we're all gonna take a little scoop of this. So you guys play with the bubbles. Now, it is gonna get a little wet, but you don't have to worry because it's only gas that's in it.
It's not.
But make sure that you guys don't touch any of the furniture or anything like that.
Excuse me, I have a question.
Whoa. Here, you can scoop it a little bit.
Can't sit on it.
You want to high five it?
You're gonna have Desmond sit down.
That's a lot of
Here,
bubbles.
take a scoop and then you can.
What?
You take a scoop like that, and then you go back like. When you get a scoop, you can go.
Just don't sit right on the couch with the scoop.
Oh my gosh, it feels so weird.
Who's next?
It pops, it pops, it pops.
I actually have some paper
I'll be
towels.
right back.
You can get a lot.
Anyone who needs paper towels, we have paper towels right here. Paper towel.
Carbon dioxide bubble.
Paper towel.
If it does, it's water, so it's like.
Oh, it's just water? Okay.
It's a little bit of water, so no stain.
Okay. There you go.
Okay. Did everyone try bubbles? Everyone want paper towel?
nothing.
Can you go sit back over there?
That will burn my hand.
Don't burn your hand.
It doesn't.
Everybody want to try? Okay.
You want to try? Last chance.
Everybody
Okay,
get
skip it if you want. It's just bubbles.
Okay.
If anyone needs paper towel, we have paper towel.
Okay. So now we're gonna move on.
Funny stuff.
Now I want to touch this.
It'll
Okay, let's all sit back down. What did you try?
I know.
You need paper towel?
I know.
Okay, now we're gonna try something else to try it. We're gonna take our boiling water again. Oh, you didn't get any? Here, just take a scoop, like, there we go. Okay, everybody sit back down. My friends, sit back down. We're just gonna let this bubble for a while. We're gonna do this again with a different reaction. So once again, we're mixing.
It's gonna overflow.
It is gonna overflow, but it's gonna
It's already
immediately.
overflowed.
So, has anyone ever seen this before?
Yes. Yes.
Is it acid?
Does it look like a penguin?
Yeah.
What looks like a It's a beaker.
I think it looks like a
Yes,
penguin.
it
I call it
does.
a penguin beaker.
It's a penguin beaker.
So, once again, we're gonna fill it with boiling water.
There's something in it.
Oh, it might have just been leftover water. So, a little more. 100 degrees Fahrenheit. Yeah. Now,
You can see a cloud.
drop
The cap on top of this thing form a cloud.
a little bit
Wait, seriously?
dry ice in here.
Oh, wow.
Here, let's make sure we're sitting down. I'm gonna hold it up so everyone can see though. But if you guys stand up, we're gonna block other people.
That's what we did last time.
I know. Yay.
That's so cool.
I'm gonna
This
come
one's
around.
even faster.
And I'm gonna make sure.
Whoa.
May I touch this?
For a ghost town.
Here, I'm gonna come around in like 10 seconds.
Why ghost
Oh,
town?
foggy.
And you put it on the floor the whole.
Okay,
Yeah, this is what you use for a DJ show.
so
Bro, yeah.
now if I put this cap on.
Whoa.
I would use that.
Shoot it up.
So
Yeah.
now
What if you
I'm
do
gonna
that?
put a little. Everybody sit back down. I'm gonna put a little bit of this inside the beaker. We don't touch the table. And you guys are gonna guess what it is after.
Syrup.
Soda syrup. Food coloring.
It's like soda syrup.
Well, it's not that. We're gonna.
That looks like lava.
I can kind of see it.
Okay, now everybody's gonna stay where they are. Okay.
Smells like cherry.
I'm gonna come around, and we're all going to
It smells like cherry.
smell it like that.
It does smell like cherry. Let me
And if you don't want to smell,
Cherry
you
syrup.
don't have to.
It smells delicious.
I want to smell it.
You wanna try it?
Oh, that smells so
Does it
good.
smell it?
I want to smell it.
Here, everyone stay where they are, so we can all try. Good. So you know.
Owen, are you okay?
No, but can you not put it so close to me?
You have like cherries, bro?
Okay. Hold on, everybody stay where they are.
Oh, it's the cherry. That is so cherry.
It sounds like a rotten.
Cherry smell.
Oh, look at that.
Yeah.
Okay, everybody gonna try?
Yeah.
I wish I could.
That smells good.
That smells like
So,
cherry.
what did it smell like?
Cherry.
Smell like
Cherry syrup. A bad, like, old Shirley Temple cherry.
No, chili temple.
No, it's a bad.
So, it's not infinite until the dry ice completely dissipates. Let's all sit back down.
Wow.
So, we just created soda.
What if you do that?
Soda.
The ingredients of soda is water, carbon dioxide, that's the bubbles, that's the fizz, and this is a little bit of syrup. It's cherry syrup, to be specific. You guys all said it was
Can
cherry.
we do other syrup?
You can totally drink this. This is just soda syrup.
That's so funny.
So,
mean.
this is literally Coca-Cola, exactly Coca-Cola. It's just a lot of carbon dioxide. It's also boiling, so you wouldn't want to drink it.
Do we have actual Coca-Cola here? Do you know?
Can we point the phone at our mouth?
We don't have Coca-Cola here. We have Kool-Aid.
Can we point the phone at our mouth? It would taste like Coca-Cola.
If you say that again,
If we point the phone at our mouth.
If you have a duck with. Can we point the phone at our mouth?
it would taste like Coca-Cola.
Can we point it?
No, I do not.
want to taste it.
I've never tasted
You don't
Coca-Cola.
have to.
It tastes so
Push
good.
it.
Yes, what's your question? Everybody listen.
What if you plug that?
If you plug that, you would not want to do that. Because the gas is creating a chemical reaction.
So it explodes.
Yes.
Excuse me?
Yes?
I mean, I've never tasted Coca-Cola before ever because I don't want too much caffeine.
Okay.
Okay.
Looks like
So
good.
Yeah,
that
so-
might be why it smelled very weird to you. Hands
Oh,
off
that's
the
the fizz.
So, yeah.
Oh
That's a lot of
no! Oh no!
We're gonna do. That's a lot of bubbles.
No, let it fizz! Let it fizz! Let it fizz! Give it
Okay.
time!
We're gonna do bubbles.
I don't
Actually,
exactly want it to.
can we go outside now? Sure. You ready? Okay, we're gonna do. Alright, I'm gonna talk for it. We're gonna do a volcano outside. Now, hold on. It's a little different than the normal paper mache volcanoes you see. This one is actually going to get extremely hot, like real lava. It's gonna get over 100 degrees Fahrenheit.
Okay, I'm gone. I'm
But
so.
it's completely safe.
I'm so. I'm gone. Alright, I'm gone.
Excuse me.
In a little bit.
We can go on it after the science guy.
After, but after.
I know.
Yeah, I'm just.
I can do a backflip easily.
We're not allowed to do it
until the science guy's done. We're not allowed to do it until the science guy's done. I don't know how to do any flips like that. I'm not allowed to do it until.
Theo, you can't even do a flip. I can do it
right now.
It's not easy in my. Theo, it's so easy. I can do a backflip.